Let's understand the next type of hybridization, namely sp hybridization. Let us take up the example so that the concept becomes clear. Formation of acetylene. Molecular formula is C2H2. Acetylene is otherwise called ethyne. Acetylene is the trivial nomenclature. Ethyne is its IUPAC nomenclature. Molecular formula of this molecule is C2H2. Let us see how this molecule is formed. This carbon atom in this case will undergo sp hybridization. So let us write the ground state electronic configuration of carbon atom. What is the ground state electronic configuration of carbon atom? Atomic number of carbon is 6 and its electronic configuration is 1s2, 2s2 and 2p2. Let us write its orbitals. So, how many orbitals of p are there? We know that p is divided into 3 orbitals because of the 3 different orientations. So 2px1, 2py1. Therefore, the 2p electrons are being filled up. So 2px1, 2py1 and 2pz is not containing any electron. Now, as the hydrogen atoms approach the carbon atom to undergo bond formation, energy gets released and the carbon atom gets excited. So let us see the excited electronic configuration of the carbon atom. So how is the excited state electronic configuration? One of the electron from the 2s energy level gets promoted to 2pz energy level. Therefore the configuration will be 1s2 and one electron has gone here. So therefore 2s1 and this one electron has come here. Therefore 2p3. So when we write the orbital diagram, how will it be? 2s will be carrying one electron and how will be the 2p energy levels? 2px, 2py and 2pz. So each one of them will be having an electron. So the configuration will be 2px1, 2py1 and 2pz1. Now, though all the 3 orbitals of the 2p energy level, which happens to be the valence energy level, is half filled. Not all of these p orbitals will undergo for the process of hybridization. Why is that it will not undergo? All the 3 orbitals of the p will not undergo the process of hybridization. It's for the reason they will form only that many number of hybrid orbitals as per the case required. Here they have to accommodate, each carbon atom has to accommodate just one hydrogen. So for suiting the need, that much of hybrid orbitals only will be formed. Though there is a possibility for them to undergo sp3 hybridization, because the requirement is not there for this case, they will undergo only sp hybridization. That means who will participate for the process of hybridization here? 2s orbital, that means one of the s orbital, and 2px orbital, that means one of the p orbitals, which are half filled and which are the valence orbitals, will undergo the process of hybridization. So this is how they undergo sp hybridization. So only 2s atomic orbital and 2px atomic orbital will undergo the process of mixing, resulting in the formation of sp hybrid orbitals. How many sp hybrid orbitals will be produced? 2, because one s and one of the p orbital is participating. That means only 2 atomic orbitals are participating. Therefore, the hybrid orbitals formed will also be 2 in number. And what is the name of these hybrid orbitals formed? Each one will be called by the name as sp hybrid orbitals. Each one of them would be called by the name as sp hybrid orbitals. Now you should remember one important thing. What is that? 2py and 2pz. They are remaining as atomic orbitals only. They have not participated for hybridization. This is the point of focus. And this is the case which is applicable for both the carbon atoms in the molecule of ethene or acetylene. It is applicable for both the carbon atoms of acetylene or ethine. So you should bear in mind that 2py and 2pz from each carbon atom is remaining as atomic orbitals. Now let us write how the hybridization would be with the exact orbital diagram. So this is the s orbital, so which is 2s. It is undergoing hybridization only with 2px. So therefore 2px. So how will be the hybrid orbitals formed? It looks like this. So what's the name? sp hybrid orbitals. So we will land up in the formation of two sp hybrid orbitals. Remember, these are not the dumbbell p-shaped orbitals. They are the hybrid orbitals because each one is like this. This is one sp and this is another sp. It is not dumbbell shape as we have written in this case. So you should take care while writing to show clear distinction between the atomic orbitals and the hybrid orbitals. Yes. Now what else has to be accommodated as per the carbon atom case of this molecule? We need to write 2py atomic orbital and 2pz atomic orbital. Let us go ahead and represent them. And remember, they both are atomic orbitals, not hybrid orbitals. So the shape should be dumbbell. That should match. So there goes. So this is our 2py and this is our 2pz. Yes, this is our 2pz. So therefore, how many like this I should be writing now? 2 like this. Why should I write 2 like this? Because there are 2 carbon atoms in the molecule of ethine which has undergone the process of sp hybridization. So let us see how the molecule gets formed. This is the sp hybrid orbital 1 and 2. So there goes its ribbon. So then what else? We need to write the 2py and we need to represent the 2pz. So this is our 2pz and 2py. This is of carbon atom number 1. Now similar case to be written for carbon atom number 2. So this is the sp hybrid orbitals. So there goes our 2py and the 2pz. This is of carbon atom number 2. Let us see what will happen. Now, between the carbon atom 1 and carbon atom 2, what happens is, one of the sp hybrid orbitals are utilized for undergoing head-on overlapping. As we know, when the orbitals undergo head-on overlapping, it will always form sigma type of covalent bond. Then what else? We see 2 hydrogen atoms. So how will this be? Let us take a look at it. Atomic number of hydrogen is 1 and its configuration is 1s1 and the shape of the orbital is spherical. And what is this orbital containing? 1 electron. So like this, 2 hydrogen atoms has to be represented because the molecular formula shows the presence of 2 hydrogen atoms. How will this be undergoing bond formation? The remaining sp hybrid orbitals from each of the carbon atom will undergo head-on overlapping with 1 hydrogen atom each. So therefore, both the hydrogen atoms are being utilized by 2 carbon atoms. Then what else happens? 2py atomic orbitals of both the carbon atoms will undergo lateral overlapping, resulting in pi bond. Then 2pz and the 2pz of each carbon atom will undergo again lateral overlapping, resulting in the formation of the pi type of covalent bond. Let us write this diagrammatically and see. This is a carbon atom number 1 we are writing. Let me write the shape properly. So now this is sp. There goes its ribbon. Carbon atom number 2. 2py and 2pz. Similarly here also. 2py and 2pz. Let me just label it. 2py and 2pz. So there goes its ribbon, sp and sp. So what has happened? They have undergone head-on overlapping, resulting in the formation of sigma type of covalent bond. Now 2py and the 2py of each carbon atom undergo lateral overlapping, resulting in pi bond. Similarly, 2pz of each carbon atom will undergo lateral overlapping, resulting in the formation of another pi bond. What else is there? So now hydrogen atom. There are 2 hydrogen atoms which will undergo head-on overlapping with carbon atom like this. There's no space there, so I will just write it. So hydrogen, resulting in the formation of sigma bond. So how is the molecule? It's a linear molecule. So how will this be? 1 carbon atom linked with other carbon atom by means of 3 covalent bonds, of which 1 is sigma bond and 2 are pi bond. How do we have 2 pi bonds here? 2py lateral overlapping, 1 pi bond. 2pz lateral overlapping, 1 pi bond. And how do we have sigma bond? sp hybrid orbitals head-on overlapping, so sigma bond. What else is there? Each carbon in turn is linked with the hydrogen, as we can see. And because spherical is the shape of the orbital of hydrogen, they always will undergo head-on overlapping, resulting in the sigma bond. So summary. What is the summary of this? This ethyne or acetylene is a linear molecule. It's a linear molecule and has a bond angle of 180 degree. How many sigma bond and how many pi bond do we see? Let's count the sigma bond first. 1, 2, 3. So this molecule contains 3 sigma bonds. and how many pi bonds? 1 and 2. So this contains 2 pi bonds. So this is how we have the formation of ethyne or acetylene molecule which has undergone sp hybridization, resulting in the formation of a linear molecule maintaining a bond angle of 180 degree and having 3 sigma bonds and 2 pi bonds in its molecule.